Today we're going to look at lesson 8-2, which is on geometric sequences. So a sequence with a common ratio between two consecutive terms is known as a geometric sequence. And it just means that you are multiplying the previous term by something to get the next term. So as you look at this sequence here, 4 times 2 is 8, 8 times 2 is 16, 16 times 2 is 32, 32 times 2 is 64. So we're constantly multiplying by the same number. Even if you see it in reverse and you see it going down, like if you were seeing it in this direction and you had 64, 32, 16, 8, and 4, we still consider it multiplying. So if it appears like you're dividing each number by something to get the next number, you're really multiplying by a fraction. In other words, dividing by 2 is the same as multiplying by 1/2. Dividing by 5 is the same as multiplying by 1/5. So your common ratio will always be considered a multiplication. So in this one, the ratio of consecutive terms of a geometric sequence is called a common ratio. So in arithmetic, we had a common difference, and in geometric, we have a common ratio. So in this particular one, as we suggested, the common ratio is 2, because we keep multiplying by 2. Given two positive numbers, the positive square root of the product of the two numbers is going to be called the geometric mean. And you had this in geometry. And in geometry, it looked like this. You had some number a is equal to x and x over b. So you had a is to x as x is to b. And because it was a proportion, you cross multiplied. So you had x squared is equal to ab. And then to solve for x squared, you took the square root of both sides. And so the geometric mean is really the square root of the two numbers that you're trying to find the mean between. You just multiply them together and take the square root. So in this particular case, you've got 3 and 48. So to find the geometric mean, you're going to take the square root of 3 times 48. Well, 3 times 48 is 144, so the square root of that is 12. Now, in geometry, we only looked at the positive value because more often than not, we only use positive values in geometry. But here, your geometric mean can be positive or negative. All right, so explicit definition. So just like with arithmetic, we have an explicit and we have a recursive formula. So with the explicit, you're going to have to memorize this and use it. You always take the first term, just like we did in arithmetic. You took the first term. So you always take the first term, but you're going to multiply it by this common ratio raised to the n minus 1. I highly suggest that you take that common ratio and put it in parentheses, because only the r is raised to the n minus 1, not the first term. Now with the recursive, if you recall, recursive comes in two parts. You have to identify what the first term is. So the first term is some number. And then you're always taking recursive the previous term. So the previous term times your common ratio. That's it. So let's look at example, let's not even number it as example 1. So example, pre-example, how's that? So how to find the ratios between consecutive terms. So if you're having trouble seeing the ratio, all you have to do is take this term and put it over 2, this term over 4, this term over 8. And you have to check all of them because they like to be funny and like make a, a sequence that would be 2, 4, 8, 32. They all have a common ratio but 1. So you got to try them all. So always take the one on the right, 4, divided by the one on the left. That should equal the one on the right, 8, divided by the one on the left, 4. The one on the right, 16. I don't know why I just put a comma instead of an equals. Over the one on the left, 8. So 4 divided by 2 is 2, 8 divided by 4 is 2, 16 divided by 8 is 2. So all of the ratios between the numbers are equivalent, so that means that R, the common ratio, must be 2. So let's look at some examples, and your job here is to determine whether each sequence is geometric, and if it is, find the common ratio R, and I also want you to write the explicit rule. So I'll do number 1 with you. So essentially you want to set each one of these over the ratio to the other, because remember what I said, you have to test all of them. So 6 over 3 equals 12 over 6 equals 24 over 12. So let's test all those. 6 divided by 3 is 2, 2, 2, so the common ratio is 2. And so yes, it is geometric. Then to write your explicit rule, a sub n is equal to, your first term is 3. I highly suggest that you put your common ratio in parentheses. In this case it's 2, and it's raised to the n minus 1. That's it. So you go ahead and try B, C, and D. So I want you to pause the video and then check your work. All right, so for B, negative 9 over 3, 27 over negative 9, and negative 81 over 27. Negative 3 equals negative 3 equals negative 3. So R is equal to negative 3. So then your explicit rule is your first term is 3. Please, you must put that negative 3 in parentheses. It's an absolute not a choice in this particular one. There's a difference between the negative 3 in parentheses and not in parentheses. They're just not the same. And then raise the n minus 1. So yes, it is geometric. So then for C, let's look at 5 over 1. Is that equal to 9 over 5? Is that equal to 13 over 9? And is that equal to 17 over 13? And none of these reduce to the same number, and so therefore no. It's not geometric. And then finally D, negative 12 divided by 48, and 3 divided by negative 12. So this reduces to negative 1 over 4 is equal to negative 1 over 4. So your R is negative 1 over 4, and so your explicit rule, a to the n, equals your first term 48 times negative 1/4 to the n minus 1. All right, so in example 2, part A, we are going to find the sixth term of the sequence. In order to find the sixth term, we could find the common ratio and multiply it 6 times. You also notice that you got positive, negative, positive. So this is waffling in between positive and negative. That means that our common ratio is negative. If you see waffling signs, your common ratio is negative. It would be easier if you just found the explicit rule and then applied it. So step 1, let's find our common ratio. So our common ratio is negative 15 over 3, and that's equal to 75 over negative 15. And so our common ratio is indeed negative 5, because both of those reduce to negative 5. So R equals negative 5. And then our rule, a sub n is equal to our first term of 3 times negative 5 to the n minus 1. And then we want to find the sixth term. And so if you apply all that, you get 3 times negative 5 to the 5th. So I'm breaking this down just in case you made a mistake. Negative 5 to the 5th is negative 3125. And so you end up with a final answer of negative 9,375 as your 6th term. So then you pause the video and do B on your own and restart it. So to find our common ratio, I'm going to take negative 32 and divide it by 64. So clearly my common ratio is going to be a fraction. And then 16 over negative 32. And so my common ratio is negative 1/2. So step 2, my explicit rule is my first term of 64 times my common ratio to the n minus 1. So now I want to find the 11th term. And so I get 64 times negative 1/2 to the 10th. 64 times 1 over 1024, which is equal to 1 over 16. Do not give me the decimal answer. And then you're done. All right, so then let's look at page 3. So in this page, you got a couple of interesting things. First and foremost, when a radioactive substance decays, the amount remaining will form a geometric sequence. So that's important. Radioactive decay, it will form a geometric sequence. So anytime that you see in the future a radioactive decay problem, you know you have a geometric sequence. You will not necessarily be told that again. So they have given you the data for the initial time and how many grams of the substance is there, and then after 2 hours, how many grams the substance is there. And you have to fill in these 3. So we can find we don't know the common ratio because we don't have 2 of them next to each other, but we can use the geometric mean to find this number. Once you have 3 numbers, then you can find the common ratio and find the other 2. So let's go ahead and first start with finding the geometric mean. Okay, so the geometric mean is going to be the square root of 1320 times 384, which is approximately 711.95. Now we want to round that to the nearest whole number because our significant digits here are whole units. So I'm going to put 712 here. Then step 2, you need to find your common ratio. So all I'm going to do is you can take any 2. So I'm going to take the 384 and divide it by 712. Or you can take the 712 and divide it by 1320. And I get approximately equal to 0.539. And then in step 3, we just need to multiply that to the 384 to get this one, and to this one to get this one. So 384 times my common ratio of 0.539. And so I get approximately equal to 207. So it's approximately equal to 207. It's like 0.1 whatever. And so the nearest whole number is 207. And step 4, I'm going to take 207 and multiply it by 0.539. And I get approximately 111.57, or depending upon what you used, whatever your decimal is, but it rounds to 112. And that's it. So again, just to recap the geometric mean, if you recall, we're just taking the square root of the product of two numbers. I don't think you really need to know what the sequence formula looks like, to be perfectly honest. Okay, so I don't know why this is not moving on me. Here we go. All right, so in a geometric sequence, the square of the middle term of any three consecutive terms is equal to the product of the other two terms. So all that they're saying is that these two terms right here, if you multiplied them together, you would get 64. And then if you took this term right here and squared it, you would get 64. That's it. Or you could find the geometric mean, 4 times 16 and take the square root of that, you'd get 8. Now, recall that if we are waffling between signs here, if I take the geometric mean of these two numbers, it could actually be positive or negative. So you have to account for the fact that you can have actually two answers there. All right, last page of notes. So let's find the geometric mean. I'm also going to show you how to find it when there is an even number in between these. So there's two ways to do it. It's easier when you have an odd number of unknown values here. So as you can see over here, there's 3 unknown values. So when it's odd, finding those numbers by using the geometric mean is much easier. So we'll just start doing these problems using the geometric mean. So in this particular one, I'm going to multiply these together and take the square root. All right, and so I get, when I multiply 45 times 80, I get 3,600. And the square root of that is 60. And of course, that number goes in between here. Now you could find your common ratio and just double check it. So if you took 60 and divided it by 45, that is 60 divided by 45. That is 1 1/3, so it's what, 4/3. So if you took this and multiplied by 4/3, you would get this, and this by 4/3, you would get this. And so it's just a way to check. All right, so that was pretty simple. Let's look at B. So with B, the more of them that you have, you're going to have to do the geometric mean more. So in other words, I'm going to take the geometric mean of these two, but it's going to give me the very center number. So let's start here. And we're going to take the square root of 972 times 12. And that is equal to hang on. All right, so 972 times 12, and then we're going to take the square root of that. Looking for my square root button. Oh, there it is. All right, so we get 108. That gives us the middle number here. Then we want to find the geometric mean again. So I'm going to find the geometric mean between these two. So the square root of 972 times 108. And then my square root is 324, goes here. And then finally, I want to do the geometric mean between these two. So 108 Of course, if you make a mistake in any of these, it's going to cause you to have an error elsewhere. So 108 times 12, and then the square root is 36. Now, of course, you could find your common ratio from here to here. From here to here, clearly we must be dividing, which is the same as multiplying by 1 over something, or a fraction thereof, and check your answers. So here's the problem. What if I had 4 blanks in between here? There would be no middle term. If I had 4 here, there's no middle term, so you can't use the geometric mean to do that. So what would you do? So let's go back over here and just look at this, and let's think to ourselves. I take 45 and multiply it by the common ratio, and I get this. If I don't know the common ratio, isn't this, or doesn't that have an equivalent value of 45 times r? And the same thing could be said here for the 80. I take 45 and I multiply it by r to get the 60, and by r again to get the 80. So to get this 80, we took 45 and multiplied it by r times r. And so 80 is actually 45 r squared. So I could have set up to find this, this is the only one where I actually know the number associated with the algebraic expression. Remember, I don't really know this. So if I took 45r squared and set it equal to 80, I could actually solve for r that way and then multiply the r to the 45 to get the 60. Plug it into here. Same thing over here. 972 is the first thing, and if I knew the ratio, the common ratio, I'd multiply it to 972 to get this, multiply this by the common ratio to get this, to get this, to get this, and so forth. So that means that and I'm going to write it down here below because I have a bunch of colors up there. So 972, comma, blank, comma, blank, comma, blank, comma, 12. So for the first blank, wouldn't I take 972 and multiply it by my common ratio? The second blank would be 972 times my common ratio twice, because I said 972 times r to get here. And then for this one, it would be 972 times r cubed, and this would be 972 times r to the 4th. So this one I'm actually going to solve and prove to you that I can actually make my way back to those answers. So I would actually then take 972 r to the 4th and set it equal to 12. To solve, I would divide by 972, divide by 972, and I get r to the 4th is equal to 12 divided by 972. Then I would want to take the 4th root of both sides in order to get my answer. So my r is going to turn out to be I'm working on it. 1/3. So then what I would do is I would take the 1/3 and multiply it to 972. So if you take 972 and multiply it by 1/3, lo and behold, you get 324. And if you take 324 and multiply it by 1/3, you get 108. And take 108 and multiply it by 1/3, you get 36. And 12 by 1/3, and you get 12. So it is possible to find it a different way. Clearly I would use this way, if at all possible, but if you have an even number here, you're going to need to use this method, and I guarantee you that's on your test. It may not be on your homework or here, but it's on your test. All right, last set of problems. So you are to write an explicit formula for these sequences and generate the first 5 terms. So I would highly suggest that you pause the video. These are easy. get your answers and then check them. So a sub n is equal to 12 times negative 1/3 raised to the n minus 1. And so a sub 1 is equal to 12 times negative 1/3 to, well, obviously a sub, I don't even know why I just did this one. Ta-da-da-da-da. A sub 1 is 12. We already knew that. Then a sub 2 is equal to 12 times negative 1/3 raised to the 2 minus 1. That is going to give you negative 4. A sub 3 is equal to 12 raised to the 3 minus 1, which is equal to 4/3. Then a sub 4 is equal to 12 times negative 1/3 raised to the 4 minus 1, which is equal to negative 4/9. Finally, a sub 5 is equal to 12 raised to the 5 minus 1, which is equal to 4/27. And your final problem is B. So with B, a sub 1, well, let's write our explicit rule. So a sub n is equal to 5 times 0.2 to the n minus 1. So since you have a decimal in your problem, you can have a decimal for your answer. So a sub 1 is equal to 5. A sub 2 is equal to 5.
Attention students.
Sorry for the interruption. All right, so then we have 2 minus 1, and so that equals 1.0. And then a sub 3 is equal to 5 times 0.2 to the 3 minus 1, which equals 0.2. A sub 4, which is equal to 5 times 0.2 to the 4 minus 1, equals 0.04, so 4/100ths. And then finally, a sub 5 is equal to 5 times 2/10 raised to the 5 minus 1, which equals 0.00881 And that is the end of today's lesson. Have fun on your homework.